Hi students, welcome to the video lectures of software engineering. So welcome to today's topic on software quality assurance or SQA we say. So this is, software quality assurance is a set of activities so which will ensure the software products meet quality goals and satisfy the customer needs. So it will cover everything from, the standards and reviews to testing until the training. Okay. So the core goal of this is to reduce the defects and maintain quality throughout the life cycle. Okay, so now if you observe the slide, so it says elements of SQA. Software quality assurance encompasses a broad range of concerns and activities that focus on management of software quality. So the standards are the IEEE, ISO, and other standard organizations have produced a broad array of software engineering standards and related documents. So standards may be adopted voluntarily by a software engineering organizations or imposed by the customer or other stakeholders. So the job of software quality assurance is to ensure that the standards that have been adopted are followed and that all work products conform to them. That is, they are being applied. Okay. Next is review and audits. Technical reviews are a quality control activity performed by software engineers for software engineers. Okay. Their intent is to uncover the errors. Audits are a type of review performed by software quality assurance personnel with the intent of ensuring that quality guidelines are followed for software engineering work. Third point is testing. Software testing is a quality control function that has one primary goal, that is to find errors. So the job of a software quality assurance is to ensure that testing is properly planned and efficiently conducted to find the errors. Okay. And fourth point, error or defect collection and analysis. So SQA collects and analyzes error or defect data to better understand how errors are introduced and what software engineering activities are best suited to eliminate them. So next, change management. Change is one of the most disruptive aspects of any software project if it is not properly managed. So change can lead to confusion and thus poor quality. So software quality assurance ensures that adequate change management practices have been instituted, that is adopted. Okay. Next is education. Every software organization wants to improve its software engineering practices. So a key contributor to improvement is education of software engineers, their managers, and other stakeholders. That is to educate them. So the software quality SQA organization takes the lead in software process improvement and is a key proponent and sponsor of educational or training programs. Okay. Next is vendor management. Three categories of software are acquired from external software vendors. Shrink wrapped packages. That is like Microsoft Office, which has everything in it, like Word, PowerPoint, Excel. And a tailored shell that provides a basic skeletal structure that is custom tailored to the needs of a purchaser. Okay. Then and contracted software that is custom designed and constructed from specifications provided by the customer organization. So the job of SQA organization is to ensure high quality software results by suggesting specific quality practices that the vendor should follow and incorporating quality mandates as part of any contract with an external vendor. So next is security management. With the increase in cybercrime, as we are seeing every day, so every software organization should institute policies that protect data at all levels because data is crucial nowadays. Establish firewall protection for web applications and ensure that software has not been tampered with internally. So SQA ensures that appropriate process and technology are used to achieve software security. Next is safety. As the software is almost always a pivotal component of human-rated systems like automotive or aircraft applications, the impact of hidden defects can be catastrophic. So SQA may be responsible for assessing the impact of software failure and for initiating those steps required to reduce the risk. And next is risk management. So although the analysis and mitigation of risk is the concern of software engineers, the SQA organization ensures that risk management activities are properly conducted and that the risk-related contingency plans have been established. Okay. So these are all the things that we discussed so far. So let me tell you again. So basically, we are talking about software quality assurance. So that is SQA, which just have a set of activities which will ensure that we are all meeting the requirements, and also we are having some quality goals, and we are satisfying the customer needs from time to time, and it covers the entire software life cycle. Okay. So now, for example, just like quality checks in car manufacturing, SQA ensures that the software is bug-free, secure, and reliable before the release. Okay. So where this SQA will ensure the developers also to follow the coding documentation and testing standards like as mentioned here, IEEE or ISO or any other company policies that have. Okay. Like for example, enforcing some standards into the product. Okay. And the reviews and audits are done by the peers where to find out the logic and design errors, and audit teams also perform regular audits, and the testing team you have a well planned, thorough and effective way to find the bugs. Okay. So they have some good testing plans that are done from time to time. And coming to error or defect collection and analysis, here we track the what errors occurred, where and why. For example, if most bugs are due to miscommunication, then just focus on the clearer requirements, right? So then it's about change management. So this is nothing but which controls let's say a small change in the code or design are made. Okay, how these changes doesn't affect, and just to avoid confusion and breakage. Okay, so for example, we just upload the codes in our Git repositories, right? So using Git branches and pull requests to manage the version control safety. And about the education part, point, training the team in best practices, tools, and quality techniques. Okay, so where the companies or the organizations will conduct some workshops on either the development or testing or something else which is very relevant. Okay, so just to improve there. Okay, and then we talked about the vendor management. Vendor management is to ensure the software from third parties meets your quality standards. Let's say, for example, Microsoft Office, okay, which is already given as an example in the slide. So, for example, adding a clause in your contracts for testing the compliance before delivery can be also vendor management. Okay. Then we talked about security management. That is, our SQA will ensure there's a secure coding and proper access controls, and also a lot of vulnerability checks have been done before we deliver it. Okay. And then about the safety part, in a safety critical systems like mentioned there, automotive or aircraft applications, the software failure can be very dangerous. Okay, so everything has to be taken care before the deployment happens, since it is going to bring a a lot of damage or havoc. Then the final one is risk management, where the software quality assurance ensures that the potential software risks are identified, documented, and mitigated. For example, if you have a backup plan, if a critical feature fails during the demo, can be the best example for risk management. Clear? So next, we talk about software quality assurance tasks. Okay, so the Software Engineering Institute recommends a set of SQA actions that address quality assurance planning, oversight, record keeping, analysis, and reporting. Okay, these actions are performed by an independent SQA group. Okay, so that will prepare an SQA plan for a project and participates in the development of project software process description, and reviews software engineering activities to verify compliance with the defined software process, and audits designed software work products to verify compliance with those defined as part of the software process, and also ensures that deviations in the software work and work products are documented and handled according to a documented procedure, records any non-compliance, and reports to the senior management. Okay, so coming to SQA, so the teams have some structured tasks to plan, track, and ensure the quality, right? So now, coming to these tasks, so these SQA teams will prepare an SQA plan and participate in the process planning, and also it reviews the activities to verify the adherences to the process, and audits the selected software artifacts. Then it documents and handles the deviations that happen and reports the non-compliance to management. For example, auditing a test case document to ensure it maps to all requirements and reporting any missing links. Okay, so that's what it's saying. So I'll just read out. The plan is developed as part of project planning and is reviewed by all stakeholders. Quality assurance actions performed by the software engineering team and the SQA group are governed by the plan. The plan identifies evaluations to be performed, audits and reviews to be conducted, standards that are applicable to the project, procedures for error reporting and tracking. So work products that are produced by the SQA group, and feedback that will be provided to the team. Then participates in the development of project software process description is the team selects a process for the work to be performed, and the SQA group will review the process description for compliance with organizational policy, internal software standards, externally imposed standards, that is like ISO 9001, and other parts of the software project plan. Then reviews software products engineering activities to verify compliance with the defined software process, which says the SQA group identifies, documents, tracks deviations from the process, and verifies that corrections have been made. Then audits designated software work products. The SQA group reviews selected work products, identifies, documents, tracks deviations, verify that corrections have been made, and periodically reports the results of its work to the project manager. Okay. Next one says this ensures that deviations in software work products are documented and handled according to a procedure. That is, if deviations may be encountered in the project plan, process description, applicable standards, or software engineering work products, okay, records any non-compliance. This point says the documents and handles deviation perfectly. Records any non-compliance and reports to senior manager. So non-compliance items, that means which is not complying to the rules or procedures. Okay, items are tracked until they are resolved. In addition, these actions, the SQA group coordinates the control and management of change and helps to collect, analyze software metrics. Right. So next we talk about formal approaches to SQA. Okay. So basically, what does this formal approaches to SQA says is, so formal methods will apply some mathematical rigor, okay, to ensure the correctness of software logic. So now let's have a look. Software quality is everyone's job. Okay, software quality is everyone's job, and it can be achieved through competent software engineering practice, as well as through the application of technical reviews, a multi-tiered testing strategy, better control of software work products, and the changes made to them, and the application of accepted software engineering standards. In addition, quality can be defined in terms of broad array of quality attributes, okay, and measured using a variety of indices and matrices. So over the past 3 decades, a small but vocal segment of the software engineering community has argued that a more formal approach to software quality assurance is required. So it can be argued that a computer program is a mathematical object. A rigorous syntax and semantics can be defined for every programming language, and a rigorous approach to specification of software requirements is available. Okay, so the formal methods will define the syntax and semantics for every program element. So used where zero errors are essential. For example, in banking systems or artifact softwares. So for example, you are proving mathematically that a login system cannot be bypassed. Can be the best example. Okay. Next, we talk about statistical software quality assurance. Okay, so statistical software quality assurance uses data and metrics to improve the quality. Okay, that's what it says. Statistical quality assurance reflects a growing trend throughout industry to become more quantitative about quality. That is, for software, statistical quality assurance implies the following steps. That is, information about the software errors defects is collected and categorized. An attempt is made to trace each error and defect to its underlying cause. Using the Pareto principle, isolate the 20%. 80% of the defects can be traced to 20% of all possible causes. Once the vital few cases have been identified, move to the correct problems that have caused the errors and defects. Understood? So what we are trying to do here is we follow a couple of steps here. So basically, first we try to collect the error data, then we analyze the root cause here. And we use this Pareto principle. So that which says 80% of bugs come from 20% of causes. Okay. So then at last what we do, we fix the few high impact issues that arises. Okay. Let us say, for example, for example, let's say if most of the bugs, okay, are in only some one module, any module, okay, since there are a couple of many modules in a project, let's say more bugs are there in one module. So here, yeah, what we have to do, we should focus more reviews and tests, right? So that will ensure your quality. Then software reliability. So software reliability means what? It is how consistent the software performs without the failure. That is reliability. Let us see the definition here. Reliability of a computer program is an important element of its overall quality. If a program repeatedly fails to perform, it matters little whether other software quality factors are acceptable. So software reliability can be measured directly and estimated using historical and developmental data. So measures of reliability and availability. If we consider a computer-based system, a simple measure of reliability is mean time between failure, that is MTBF equal to MTTF plus MTTR. Okay, that is the mean time to failure and mean time to repair respectively. So MTBR is a far more useful measure than other quality related software metrics. So an end user is concerned with failures, not with the total defect count, right? Because each defect contained within a program does not have the same failure rate. So the total defect count provides little indication of the reliability of the system. So in order to make you people understand this, let's consider an example, okay, where an application that crashes, let's say, let me write. So here, you know, the formula now, where MTBF equal to MTTF plus MTTR. What are these things? What I'm trying to tell you here, that is mean time between failure is calculated by the addition of mean time to failure plus mean time to repair. So now I'm taking an example of an application. So which let's say that crashes some so once in every 7 days, that is a week. Okay, so weekly once that crashes, let us assume. Okay, and let us say the MTTR for that particular crashed application is 2 hours. That means we are taking 2 hours to fix that particular crash, right? Now the MTBF is what? MTBF becomes what? That is 170 hours, right? So now you can understand by this example how the MTBF is calculated. Next, the ISO 9000 quality standards. So basically, what is this? So this ISO 9000 is considered to be a universal quality standard, okay, which will ensure the software processes that will meet consistent documented practices. So a quality assurance system may be defined as organizational structure, responsibilities, procedures, processes, and resource of implementing quality management. So quality assurance systems are created to help organizations ensure their products and services satisfy customer expectations by meeting their specifications. Okay, so ISO 9000 describes quality assurance elements in generic terms that can be applied to any business regardless of the product or services offered. So to become registered to one of the quality assurance system models contained in ISO 9000, a company's quality system and operations are scrutinized by the third party auditors. This is what is important point for compliance to the standard and for effective operation. So upon successful registration, a company is issued a certificate from a registration body represented by the auditors. Got it? So basically, the key elements in 9001 are we define and document the quality policies, we track the training infrastructure, and we ensure the compliance with reviews. And then we take some necessary actions. Clear? Then we talk about the outline defines the basic elements of ISO 9000 2000. So that is what I told you just now. Elements establishes the elements of quality management system and document the quality system. support quality control and assurance, establishes the reviews mechanisms, identify quality resources, define method for remediation. That is to how to mitigate. Clear? So these are the 7 principles of ISO 9000 are depicted in the image below. Okay. So that is customer focus. Okay. Leadership, engagement of people, process approach, improvement, evidence-based decision making, relationship management. So all these 7 are quality management principles. Then we talk about the SQA plan. What is SQA plan? SQA plan provides a roadmap for instituting software quality assurance developed by the SQA group. The plan serves as a template for SQA activities that are instituted for each software project. So what are the steps to develop and implement a software quality assurance plan? So these are the steps. Step 1, we have to document the plan. Okay. So these are all the steps. Okay. Then step 2 is to obtain management acceptance. Step 3 is to obtain development acceptance. Step 4 is plan for implementation of SQA plan. Step 5 is execute the SQA plan. Understood? So now the SQA plan is the master document for all quality activities in a project. Okay. So what it is including? It includes the purpose, roles, references, testing, documentation standards, error tracking and change control, tools used, review and audit details, all these things. Clear? So, for example, before we start a, let us say, an healthcare application, the software quality assurance team defines every activity in SQA plan to ensure regulatory and safety compliance, right? So that's it, students. So in a summary to speak, so software quality assurance is a multi-dimensional effort. Okay. Multi-dimensional effort in the sense it is covering everything, almost the planning part, testing, training, auditing. Okay. Not only that, it also ensures you that software is not only the bug free, but also secure, safe and maintainable and reliable. And also adding to the point, the latter slide speaks about the quality standards like ISO 9001, where the statistical analysis and strong planning teams, where they can consistently deliver the high quality software. Clear? Thank you, students.